So let us start with some questions, right? So in this question, the equation of motion of particle executing SHM is given: a plus 16 pi square x is equal to 0. So you have to find the displacement is in x direction and you have to find the time period. Okay, so in this question, the standard equation of the simple harmonic motion. So this is the acceleration and the displacement. Acceleration is what? Say d square x upon dt square plus 16 pi square into x is equal to 0. It is given, right? So you have to find the time period, right? So to find time period, you just compare this equation with omega square into x is equal to 0. Is it clear or not? So if this is the standard equation and this is the given equation, so the omega square is nothing but 16 pi square. It is equal to 4 pi, may be written as 2 pi by t, and this is the 4 pi, and t is equal to 1 by 2 seconds. So the time period of this simple harmonic motion is 1 by 2 seconds. Copy this. So in this question, the displacement of the particle SHM is represented by the given equation. What is the y? The displacement of particle performing SHM is, this is sine, right, 3 pi t plus pi by 4. It is in meter. So and you have to calculate time period, initial phase, and the displacement from mean position. So first, the time period. So to find the time period, you compare a sine omega t plus phi. All right. And what is the omega? Say it is 3 pi. It is equal to 2 pi by t is equal to 3 pi. Is it clear? So t is equal to what? Say 2 by 3 seconds. So this is the time period, right? And what is the initial phase, you tell? The initial phase is phi. The initial phase is phi is equal to pi by 4. Is it clear or not, you tell? This is the initial phase. And what is the third part? They are asking the displacement from the mean position at t is equal to 7 upon 36 seconds. So how to find this displacement, you tell? Just put the value in this case. This is the displacement as a function of time t. So if you put the value of t over here, right, 0.08 sine, this is 3 pi. What is the value of t? 7 upon 36 plus pi by 4. You just calculate 12. This is 7 pi upon 12 plus pi by 4. The LCM is 12, right? 7 pi plus 3, right? 4 3 is 12. So this is 10 pi by 12. It is equal to 5 pi by 6. So the displacement is 0.08 sine 5 pi by 6. Is it clear or not? So what is the 5 pi by 6? Sine pi minus pi by 6 is equal to 5 by 6 is equal to sine pi by 6. The pi by 6 value is sine 30 and which is equal to 1 by 2. So 0.08 and its value is 1 by 2 is equal to 0.04 meter is the correct answer. So this is the displacement at t is equal to 7 upon 3 seconds. Is it clear? Copy this. So in this question, two SHMs are given by y1 and y2, right? You have to find the ratio of their amplitude and the phase difference between them. For example, in this case, the y1 is given as 10 sine 3 pi t plus pi by 4, and the second equation is given as 5 sine, right, 3 pi t plus root 3 cos 3 pi t. Is it clear or not? So listen one. When the sine a, this function is given and the frequency is same, 3 pi t and 3 pi t, right? So whenever it is this type of thing is given, so you have to convert this into a one terms. What is the coefficient of sine? Say 1. Coefficient of cos is root 3. So you have to divide and multiply, right, by 1 square and root 3 square. The coefficient of sine and coefficient of cos ka whole square. That b, this is equal to what? Root over 1 square root 3 square multiplied and divide, right? So this is how much? This is 1 plus 3 is equal to root 4 is equal to 2. So you just multiply by 2 and divide it by 2 sine 3 pi t right, plus root 3 by 2 cos 3 pi t. Is it clear or not? So this is 10. It may be written as sine 3 pi t into, this is what? Say cos 30, cos 60 cos pi by 3 plus cos 3 pi t into sine pi by 3. Sine pi by 3 mean root 3 by 2. It is equal to 10. Now you can apply sine A plus B formula. Sine A cos B, cos A sine B. 3 pi by 2 plus pi by 3. So the second equation is this. So this is the y1 equation, this is the y2 equation. Are you getting? This is the phase of the SHM1, this is the phase of the SHM2. Is it clear? This is the amplitude 1, right, and this is the amplitude 2. So they are asking the ratio of the amplitude. So the 10 upon 10, the amplitude is same, so ratio is 1. And also in the second part they are asking the phase difference, right? So what is the phase difference? Utal phase difference, right? The phase difference delta phi is phi 2 minus phi 1. So I am writing this side. The phase difference is, this is the phi 2, mean 3 pi t plus pi by 4 minus 3 pi t, sorry, this is pi by 3 minus 3 pi t plus pi by 4. It will cancel. So pi by 3 minus pi by 4. So it is 12. 4 pi minus 3 pi is equal to pi by 12. So what is the phase difference? Pi by 12. Is it right? Copy this. So in the next example, the particle perform SHM, amplitude is 5 centimeter, time period is 4 seconds. If timing is start when the particle is at the center of the oscillation, that is at x is equal to 0, you have to find frequency, displacement, maximum acceleration and the velocity of the particle, right? So listen one thing. So in this example, what is given? The amplitude 5 centimeter, the time period is 4 seconds. So therefore omega is equal to 2 pi by t. 2 pi by 4 is equal to pi by 2 radian per second. It is given, right? So in the first part they are asking the frequency, which is equal to 1 by t. So 1 by 4 is equal to 0.25 hertz is the frequency. In the second part, although at t is equal to 0, right, the particle start its motion from the mean position. This is the minus a, this is the plus a, right? So if particle is 0 at t is equal to 0, the x is equal to 0, the equation of the displacement is a sine omega t. Is it clear or not? So they are asking then displacement. What is the amplitude? Say 5 sine. What is the omega? Say pi by 2 into t. Is it clear or not? Utal. So this is the xt. So at t is equal to 0.5 second, they are asking the displacement, right? 0.5 second. So you will put 5 into sine, pi by 2 into 0.5. Is it clear or not? So this is 5 into sine, and this is, it become pi by 4. So 5 into 1 by root 2. So the displacement is 5 root 2, right? And it is in centimeter. So this is the displacement of the particle at 0.5 second. Is it clear or not? Right. Now, what is the maximum acceleration? The maximum acceleration is the extreme position, and it is equal to a omega square. So value of wave max is a omega square. What is the a? 5. What is the omega? Say pi by 2. It is in 5 in centimeter. So 5 pi square by 4. This is centimeter square per second is the value of maximum acceleration. Is it fine? In the fourth part, velocity of the particle, right? So how to find the velocity? Is equal to dx upon dt is equal to a omega cos omega t, right? And the time, okay, listen one thing. The velocity at the displacement 3 centimeter we have to find. So then we will not use this formula, rather omega root a square minus x square we will use. Omega value is pi by 2, a square is 5 square, x is 3 square, right? So this is equal to pi by 2, 25 minus 9, pi by 2, into root 16 pi by 2 into 4 is equal to 2 pi centimeter per second. So 2 pi centimeter per second is the velocity when, although it is 5 centimeter, the amplitude is 5 centimeter, when the particle is at x is equal to 3 centimeter. Here extreme position the velocity is 0. Here the velocity we have found, it is 2 pi centimeter per second, right? Copy this. So in the next example, particle execute SHM from extreme position and cover a distance equal to half of its amplitude in 1 second. Determine the time period of the motion, right? For example, the particle is starting its motion from at t is equal to 0. It is at plus a, right? It is 0, it is minus a. Are you getting or not? So it start from here, right, and cover the half of the amplitude, mean the particle start and reach at this point, and the displacement, this is the total time taken is 1 second. Is it clear or not? All right, so listen one thing. This can be done in two ways. I told you in the theory that from x is equal to 0 to a by 2, the time taken is t by 12, right? If the capital T is the time period, its time is t by 12 and its time is t by 6. So directly we can do from here to here, the time is t by 6 and it is given in the question 1 second. So t is equal to what? 6 seconds from here to here. So what they are asking in the question? The time period. So 6 seconds is the correct answer. This is the one thing. Another thing, listen one thing. This is the method 1, which is easy and you must remember. By the method 2, what you have to do? If it start from extreme position, the equation is given by a cos omega t, right? Because at t is equal to 0, the initial phase is pi by 2, right? So at t is equal to 1 second, listen one thing, t is equal to 1 second. What is the displacement? The displacement become a by 2, or the position from the mean position, the x value become a by 2 at 1 second. So it is 1 by 2 into cos omega. So this is equal to cos pi by 3. So pi by 3 is equal to omega is equal to 2 pi by t. So pi will cancel out, t is equal to 6 seconds. This is the method you can use to get the answer, right? Copy this. So in this case, in this question, amplitude of oscillator is a. You have to find the velocity of, when the velocity of the particle is half of the maximum, you have to find the position. So to solve this question, right, we will use the formula of the velocity as a function of x like this, right? So they're saying when the velocity is half of the maximum velocity, what is the maximum velocity? Say omega. So this velocity become half of the maximum velocity, and in that case you have to find the value of x. Omega will cancel out, a by 2 root over a square minus x square. Simplify this, a square minus x square, right? So x square is equal to a square minus a square by 4. It is equal to 3a square by 4. This is the x. So x value is plus minus root 3 into a by 2. So these are the two positions of the particle when the velocity is half of the maximum value, right? Copy this. So in the next example, the velocity of a particle in SHM at position x1 and x2 are v1 and v2 respectively. Determine the value of the time period and the amplitude, right? So in this case, we will again use the formula like this. So at position x1, right, at position x1 the velocity is v1, and at position x2, right, the velocity is v2. Is it clear or not? So now you have to find the amplitude and the time period. So this is the equation number 1 and equation number 2, right? So 1 divided by 2, if 1 divided by 2, right, what we have to do, you have to find the acceleration. v1 upon v2 is equal to omega. Simplify this, right? Omega will cancel out, make the square both side, a square x2 square. All right. So cross multiply v1 a square minus v1 x2 square, v2 square a square minus v2 square x1 square. A square, if it is common, right, this side v1 square x2 square minus x1 square. Is it clear or not? So a square is equal to what? v1 square x2 x1 square divided by v1 square minus v2 square. All right. So the amplitude is given as, right, I am writing here, the amplitude is square root of v1 square v2 square v1 square minus v2 square. Is it clear or not, you tell? If this is the amplitude, this is the one thing. How to find the omega? Listen, make it square, v1 square omega square a square minus x1 square. Make it square, omega square a square minus x2 square, right? So this is the v1 square omega square a square minus omega square x1 square. Fine. v2 square is equal to omega square x2 square. Is it clear or not? So if this is the equation 1, equation 2, 1 minus 2, v1 square, this is the equation 1, this is the equation 2, right? So if you subtract them, it will cancel. v1 minus v2 square, the minus omega square x1 square plus omega square x2 square. So if you take omega square common, x2 square, right? So omega square may be written as upon x2 minus x1 square. Omega is equal to v1 minus v2 upon x2 minus x1 square is equal to 2 pi by t, and t is equal to what? 2 pi root x2 minus x1 square upon v1 minus v2 square, right? So this is the time period and this is the amplitude. Okay, copy this. So in the next example, particle execute SHM having amplitude 0.01 meter and frequency 60 hertz. Maximum oscillation you have to find. The amplitude is 0.01 meter. The frequency is 60 hertz, right? So what is the A max formula? Say right, A omega square. A is 0.01, omega is 2 pi f whole square, 0.01 2 pi 60 whole square, 0.01 120, 0.01 120 square into pi square, 0.01 it is 144 into 100 pi square is equal to 144 pi square, right? Meter per second square is the maximum oscillation. Copy this. So in the next example, particle perform SHM found at equilibrium position at t is equal to 1 second and found to have a speed 0.25 meter per second at 2 seconds. If the period of oscillation is 8 seconds, you have to find the amplitude, right? So in this example, at t is equal to 1 second, right, particle is at equilibrium position, right? And to have a, and the at t is equal to 2 seconds, the speed of the particle is 0.25 meter per second. So with the help of this data, first we will find the particle equation. So suppose the equation of the particle performing SHM is this: a sin omega t plus phi is the initial position. So at t is equal to 1 second, right? It is 1 second. What is the position? Say 0. So it is sin omega plus phi. Is it clear or not? Also the time period of oscillation is 8 seconds. So omega is equal to 2 pi by 8 is equal to pi by 4. Fine. So if 0, it means sin 0 is equal to sin omega plus Omega mean pi by 4 plus phi. So it means 0 is equal to pi by 4 plus phi. So initial phase may be minus pi by 4, or it may be 3 pi by 4 also, right? So the equation of the SHM is a sine omega t plus phi. Omega is what? Say pi by 4, t minus pi by 4. Is it clear or not? You tell. This is the x. And also they have given the velocity. So how to find the velocity? Differentiating this dx upon dt. So sine differentiation is cos, and again differentiation a into omega. I think you are getting the differentiation. And velocity at t is equal to 2 seconds. Velocity is 0.25, right? The velocity is 0.25 meter per second. V is equal to a pi by 4 cos pi by 4 into t. What is the value of t? I will put 2 minus pi by 4, and the velocity become 0.25, mean 1 by 4 meter per second, right? This 4 will cancel out. A pi cos, this is pi by 4 if you calculate. Are you getting? So 1 is equal to a into pi into 1 by root 2. So root 2 is equal to a into pi. Amplitude is equal to root 2 upon pi. And what is the unit? So it is in meter. So this is the amplitude. What they are asking? So amplitude is root 2 upon pi meter is the correct answer. Copy this. So in this question, particle execute SHM, complete 1200 oscillation per minute, passes through mean position with velocity 3.14 meter per second. You have to find displacement from its mean position. Also obtain the displacement equation of the particle if displacement is 0 at t is equal to 0, right? For example, what is given? Oscillation per minute, 1200 oscillation per minute, right? Yani ki, what does it mean? 1200 oscillation, right? Oscillations in 1 minute means 60 seconds. So one oscillation will be completed in this much seconds, is equal to a into 2. So amplitude is equal to 1 upon 40 meter. This is the amplitude. Maximum displacement of the particle. Okay, so what is the maximum displacement from the particle from mean position? So the maximum displacement is nothing but equal to the amplitude, is equal to 1 upon 40 meter, or 100 upon 40, right, centimeter. This is 5 by 2, 2.5 centimeter. 2.5 centimeter is the maximum displacement. Also find the displacement equation. How to find? X is equal to a sine omega t plus phi. Listen one thing, at t is equal to 0, x is equal to 0, mean a sine 0 plus phi, and the x is 0. So what is the sine phi? Sine phi is 0 is equal to sine 0. So phi may be written as 0 or pi. Fine. So therefore x is equal to a sine omega t plus 0. I am taking the initial phase to be 0, right? Phi 0. X is equal to a 1 upon 40 sine the omega. Omega value is 2 pi by t. 2 pi 1 upon 20 is equal to 40 pi radian per second. So it is 40 pi t plus 0. X is equal to 1 upon 40 sine 40 pi t is the equation of the displacement of the particle performing SHM, right? Copy this. So in the next example, particle oscillates along x-axis according to the wave 0.05 sine 5t minus pi by 6. You have to find the velocity at t is equal to 0. So it is very simple. Velocity is nothing but dx upon dt, 0.05 sine differentiation is cos, right, and differentiation it again into 5 because it is 0. 5t ka differentiation is 5. It is 0.25 cos 5t minus pi by 6. This is the velocity as a function of time t, and t is equal to 0. The velocity you have to find 0.25, right? And cos 0 minus pi by 6. This is equal to cos pi by 6, cos 30 mean root 3 by 2. So 0.25 into root 3 by 2. Is it clear? So 0.25 may be written as 1 by 8. Getting or not? So it is equal to root 3. So velocity at 0, root 3 upon 8 meter per second is the correct answer. Right? Copy this. So in this question, particle executing SHM, equation is given and the initial displacement of the particle is 1 centimeter and initial velocity is pi centimeter per second. You have to find the amplitude and the initial phase. Right. So in this case, the x is equal to a sine pi t plus phi. Right. Initial displacement mean at t is equal to 0, the displacement is 1 centimeter. A sine 0 plus phi. So 1 is equal to a sine phi. This is the one thing. The another thing, the initial velocity. How to find the velocity? Say by dx upon dt is equal to a pi. If you differentiate, it is cos pi t plus phi. Right? This is the phi. So the initial velocity is pi is equal to a at t is equal to 0. The velocity is pi, a pi cos pi, it is 0 plus phi. So it is 1 is equal to a cos phi. So this is the equation number 1. Equation number 2, what we have to find? The amplitude and the initial phase. So to find the amplitude, square the equation 1 and 2 and add. So this is 1 square plus 1 square is equal to a square sine square phi plus a square cos square phi. If you take a square common, sine square phi plus cos square phi is equal to 2. It is equal to 1, so 2 is equal to a square is equal to root 2, right? Centimeter. So the amplitude is root 2 centimeter. Is it clear or not? Now, if amplitude is root 2, so we can find the sine phi is equal to 1 upon a is equal to 1 upon root 2 is equal to sine pi by 4. So the phi is equal to pi by 4. So this is the initial phase, and this is the amplitude, right? Copy this. So in the next example, a body executing SHM has its velocity 10 centimeter per second and 7 centimeter per second when its displacement from mean position are 3 centimeter and 4 centimeter respectively. Calculate the length of its path, right? So listen one thing. When a particle performing SHM, this is the mean position, this is the plus a and this is the minus a. So particle is executing SHM in this way, like this, right? Like this. So what is the length of the path is 2a. This is the first thing. And they have given the velocity. We will use this formula a square minus x square. The velocity has 10 centimeter per second when the mean position displacement is 3. Velocity 7 when the mean position displacement is 4. Right. So we have to find the value of a with the help of this. To find this, just square them and divide. This is the equation number 1, equation number 2. Right. 1 square and 2 square you have to do. So this is the omega square, a square minus 3 square, omega square, a square minus 4 square. Only then you can find the amplitude. It is 100 minus 9 upon a square minus 16. Multiply 100 a square, 1600, a square 49, a square minus 49 into 9. 9 निम 81, यहाँ से लग गया a, 9 चौक 36 और 8, 44, 441, right? So when you will simplify 51 a square, 1600 minus 441, right? It is 1600 minus 441, 9, 5, right? 1, 1. So this is 1159. So the a square is 1159 upon 51, right? simplify this and the length may be written as 2a. The amplitude is root 1151, right, like this, 1159, and the length can be found with the help of 2a. All right, so when you will divide by 51, you will get 2.75, and the square root of this is 4.76. So therefore the length of the path is 4.76 multiplied by 2, and you will get 9.53 centimeter is the correct answer, right? Copy this. So in the next question, right, particle executing SHM time period is 4 seconds. What is the time taken by it move from mean position to half of the amplitude and extreme position to half of the amplitude? So this thing we have done many times also in the theory. Listen, from mean position to half of the amplitude, and the second case extreme position to the half of the amplitude. So this time is T1 and this time is T2. Although in this case the capital T is given as 4 seconds. So first, mean position to half of the amplitude. The time is T1 is equal to T by 12. This is 4 upon 12 is equal to 1 upon 3 seconds. Second part, extreme position to half of the amplitude. It means they are asking the extreme to half of the amplitude. The T2 is T by 6. This is 4 upon 6, 2 upon 3 seconds. So this is the solution. Copy this. So in this example, the particle undergoes SHM having time period capital T. You have to find the time taken to complete 3 by 8 oscillation. Listen one thing. 3 by 8 oscillation mean it is 2 by 8 plus 1 by 8. It means 1 by 4 plus 1 by 8 oscillation. Right. You consider if a particle is performing SHM, this is the 1/4 oscillation, the other 1/4, 1/4, and remaining 1/4 oscillation. So from here to here, to complete the 1/4 oscillation is the time taken is T by 4. Right. This is the 1/4 oscillation. And what about the 1/8 mean? The half of the 1/4 oscillation mean the particle move from here to here, then it move at the a by 2. Is it clear or not? So this is the 1/4 and this oscillation is what? 1/8 oscillation. So what is the time T2 from here to here? It is T by 6 if you remember. So what is the total time? Total time, tell me. Total time is T by 4 plus T by 6. Listen, this T by 4 is to complete the 1/4 oscillation, and this is the T by 6 is the time to complete the 1/8 oscillation. 1/4 plus 1/8 is equal to 3 by 8 oscillation. So the answer will be, we have to add them. 24 is the LCM. 60 plus 40 is equal to 10t plus 12. 10t plus 24 is equal to 5t plus 12. So the total time taken to complete 3/8 oscillation is T by 4 plus T by 6. T by 4 plus T by 6 is equal to 5 capital T by 12. All right, copy this. The displacement of the particle in this question in the SHM is given by y is equal to 10 sine 60 plus pi by 3. Right. Here y is in meter, t is second. Find the initial displacement and velocity of the particle. Okay. So initial displacement mean at t is equal to 0, they are asking the y. Right. If I put t is equal to 0 over here, so the initial position or the initial displacement, if put t is equal to 0, we can find. Right. So this is 10 sine 60 pi by 3. It is 60, 10 root 3 by 2 is equal to 5 root 3. Right. It is in meter. So this is the initial displacement at t is equal to 0. The second part, what they are asking? They are asking the initial velocity. Right. So how to find the velocity? The velocity would be found dy upon dt. If you differentiate this, it is 10 into 6 cos 60 plus pi by 3. Right. So velocity is 60 into cos 60 plus pi by 3. this is the velocity as a function of time t. At t is equal to 0, the velocity is cos 0 plus pi by 3. It is 60 into cos pi by 3. 60 into 1 by 2 is equal to 30 meter per second is the correct answer. Alright, copy this. So, in the next example, for a particle executing SHM, in which part of the oscillation the oscillation support the velocity and oscillation oppose the velocity? Right, this is the good question. Listen one thing. When a particle is performing SHM from x is equal to 0 to plus a, when particle is going the velocity direction in this way, so the oscillation will be in the opposite direction. So from when the particle is moving away from the mean position, the oscillation oppose the motion, right? And when the velocity is towards the mean position, when particle is returning back to its mean position, the oscillation is supportive. So in this way, for this part, the oscillation oppose, right? Oppose. Here in this part, the oscillation support. When the particle velocity is away from the mean position, the oscillation is opposite. Is it clear or not? When it is going in this direction, oscillation oppose. When it move in this way, right? So this is the direction of the velocity, and also the oscillation is always toward the mean position. The oscillation, whether particle is going away or towards, the oscillation is always towards mean position. So when it is returning back to the mean position, it support. All right. So this is the solution of this answer. So in this question, listen one thing. Particle is performing linear SHM between the 2 point A and B 10 centimeter apart. Take the direction A to B as positive and give the sign of the velocity, oscillation and force on the particle. Listen one thing. In this case, this is the A and this is the B. Take this direction to be positive and it is performing SHM between this and this is the 10 centimeter apart. Mean the amplitude is 5 centimeter, right? This is assumed to be x is equal to 0. This is plus 5. This is minus 5. Is it clear or not? So we have to find the direction. So A part at end A, when the particle, this is the sign of velocity, sign of oscillation and sign of force. When A at end A, when the particle is at end A, what is the velocity? Velocity is 0. What is the oscillation? The oscillation will be in this direction. So this is positive. What is the force? The force is equal to m into a. Force will be along the oscillation. So it is positive. Is it clear or not? B part. When it is at end B, right? At end B. What is the velocity? Say 0. What is the oscillation? Say negative, because this direction is taken as the positive and this direction therefore is negative. So this is the oscillation, negative. The force is also along the direction of the oscillation, say negative. Is it clear or not, Uter? Now C part. What is the C part? At the midpoint of AB, midpoint of AB, this is the midpoint, going towards A. If it is going towards A, what is the sign? The C part, right? Going towards C part. What is the direction of velocity? Tell. It is negative. When it is moving in this direction, the oscillation is in this direction, positive. If this is the acceleration, force is also positive. Is it clear or not? The D part. What is the D part? 2 centimeter away from B. Away from B. 2 centimeter away from B, going towards A. This is the D part position. This is the 2 centimeter away from B, going towards A. So this is the velocity direction. Velocity direction is negative. When it is in this direction, the acceleration is also in this direction. It is negative and the force is also negative. It is clear or not? What is the E? The E part. At 3 centimeter away from A, going towards B. This is 3 centimeter and the particle is over here and going towards B. So if particle is at this point 3 centimeter away from A going towards B, so what is the direction of the velocity? Say positive. And what is the acceleration towards mean position? Say positive. And therefore the force is also positive. The next and last part, 4 centimeter away from A, the 4 centimeter away from A and going towards A, it means the particle is at this point and going towards A. This is the 4 centimeter and towards A. So going towards A, what is the direction of velocity? Say negative. It is going in this direction, acceleration is in this direction, positive, therefore force is positive, right? This is the solution of this question. Copy this. So in the last example, piston in the cylindrical head locomotive has a stroke twice of the amplitude. Amplitude stroke has the 1 meter and twice of the amplitude. If the piston move with SHM, angular frequency is given 200 radian per minute. What is its maximum speed? Listen, suppose this is the cylinder and here it is a piston. So piston move up and down like this, right? And the length of the stroke is say 1 meter and this is equal to amplitude. So amplitude will be equal to half, this is the amplitude, half of the length of the stroke. Is it clear or not? So amplitude is 1/2 meter it is given, and what is given, the angular frequency is 200 radian per minute. Radian per minute mean radian per minute. 1 minute 200 radian per 60 second, right? So 10/3 radian per second is the angular velocity. What is the maximum speed at the mean position? You will say A omega. So the maximum speed is A omega. A is 1/2, omega is 10/3, 5/3 radian per second. Is it clear? You can convert into in minute. This is radian per second, 5/3 radian per minute mean 1/60, right? It is 100 radian per minute. Sorry, this is in meter per second, right? This is in meter per second, meter per second, meter per second. 100 meter per minute is the maximum velocity. Is it clear? Copy this.